All right, today we're going somewhere pretty wild. We're heading about 240,000 miles away to the moon's south pole. Now, this is a place of incredible promise, but also immediate, deadly peril. It's a place that could literally unlock humanity's future in space or, end it in an instant. This is the story of a brand new lunar gold rush, where the treasure is priceless and the environment is one of the most lethal places you can possibly imagine.
So let's just get right to the big, obvious question. Why on earth are we spending billions of dollars and taking these massive risks to send people to a spot so hostile that, without protection, you wouldn't even last a few minutes? Why? What's the sudden rush to go back to the moon, and why specifically to its most dangerous neighborhood? Well, the crazy thing is, the answer is hiding in the very thing that makes it so deadly, these permanent sunless shadows in the bottom of deep polar craters. What's lurking in that darkness is valuable enough to completely rewrite the future of space exploration. And you've got to understand, this is not a repeat of the 1960s. This is a whole new kind of space race, with new players from all over the world. And it's driven less by planting flags and more by a strategic hunt for resources. A hunt for buried treasure with absolutely massive geopolitical stakes. You see, the whole point of NASA's Artemis program isn't just to leave some footprints. The goal is to build a permanent base at the lunar South Pole. And the reason for that exact spot, the prize that's driving this entire thing, is water. Not liquid water, of course, but huge deposits of ancient ice that have been frozen solid for billions of years. But here's the catch. To get to that prize, astronauts will have to survive an environment that makes the most extreme places on Earth look like a walk in the park. So let's talk about the main villain in our story today, the killer cold. In the depths of these craters, where sunlight has literally never reached, the temperature drops to a mind-boggling -250 degrees Fahrenheit. Just let that sink in. That's not just cold, it's a kind of cold that acts in ways that are totally alien to us. To put that number into perspective, the coldest temperature ever recorded here on Earth, in Antarctica, was about -129 degrees. The lunar shadows are nearly twice as cold. In fact, these spots on our own moon are actually colder than the surface of Pluto, a dwarf planet that's almost 40 times farther away from the sun than we are. And this is what that kind of extreme cold really means. The heat would just be ripped from your body so fast that your tissues would become incredibly brittle. Any impact, any sudden movement, and you could literally shatter like glass. So how do you even operate in a place like that? Well, the solution isn't about building some kind of super-powered furnace. It's about a much more elegant piece of physics. And it's one of the key technologies that makes lunar survival even possible. It all starts with a really basic concept: infrared radiation. Your body, it's a heat engine. Right now, as you're sitting there, you are constantly radiating your own body heat out into the world as invisible infrared waves. Here on Earth, the air around us, the molecules, they slow down that heat loss. But in the vacuum of the moon, there's nothing. Absolutely nothing. Your vital body heat just escapes into the void, totally unchecked. It's like leaving every single window and door of your house wide open during a blizzard. This is where this incredibly clever reflective insulation comes in. A perfect example is a tech called omni-heat, which uses a really lightweight material with tiny metallic dots all over it. As your body radiates that heat outward, this metallic surface acts like a mirror, but instead of reflecting light, it catches those infrared waves and bounces them right back at you, essentially recycling your own body heat. The whole process turns your own body into a self-contained heating system. You're not fighting the cold with brute force, you're just stopping your own life-sustaining heat from getting away. It is a brilliantly simple, elegant solution to a very lethal problem. Okay, so we figured out how to survive the cold. Now let's get back to the prize itself. And look, the technical challenge of actually mining this ice in a vacuum is going to be immense. But the reason we're so determined to try is because that frozen water, it's the key to everything. I mean, it seems almost boring, doesn't it? Water. We have oceans full of it here. But on the moon, water isn't just water. It's potential. It is the single most valuable resource you could ever hope to find off-world. Just think about what that water ice gives you. First, you melt it. You've got drinking water. That's gift number one. Then, you use electricity to split the water molecule, H2O, and you get breathable oxygen. That's gift number two. But the third gift is the real game changer. That same process gives you hydrogen and oxygen, which are the two main ingredients for the most powerful and efficient rocket fuel we know how to make.
And that is why this is such a huge deal. Getting off Earth is incredibly expensive, mostly because a rocket's weight is just the fuel it needs to lift its own fuel. But if you can make that fuel on the moon, which has only 1/6 of Earth's gravity, the cost of exploring the rest of the solar system just plummets. Suddenly, the moon isn't just a place to visit anymore. It becomes a refueling depot, a cosmic gas station. And that opens up some massive questions. Who gets to control this resource? It's the critical piece of the puzzle that makes missions to Mars and beyond actually affordable. And believe me, everybody wants a piece of that action. All of this, the technology, the risk, the incredible reward, it's all pushing us into a brand new lunar age, one where our future out among the stars is going to be decided right there, in these dark, frozen craters.
And that's really the central paradox of the moon's south pole, isn't it? The permanent shadows are what make it lethally cold. But those exact same shadows are what have protected these ancient ice deposits from the sun for billions of years. The danger and the opportunity are literally two sides of the same coin.
So our whole way of thinking about the moon is changing. For 50 years, it was a place we went to and came back from. Now it's becoming a resource we can use, a stepping stone to the rest of the cosmos. And that leaves us with one final thought. In this new lunar gold rush, we're staring down one of the most hostile environments we know of, to unlock one of our greatest hopes for the future. So which one of those two powerful forces, the lethal cold or the life-giving ice, is ultimately going to shape our destiny out there in space?